This video is about solutions to systems of equations. So to start with a review, a system of linear equations is a set of two or more linear equations. An example might be something like y equals 3x plus 2 and y equals 4x minus 1. The solution to a system of linear equations is the ordered pair that satisfies both equations. So remember, if we were to graph these two lines, our solution would be the point of intersection, the point that lies on both lines, the point that makes both equations true. So our solution is the ordered pair that satisfies both equations. When we think about systems of linear equations, we have three different types of solutions. We have unique solutions, inconsistent solutions, and dependent solutions. And we're going to talk more about those right now. So starting with unique solutions, these are system of equations that have only one answer or one shared order pair where the two lines intersect. So when we look at this example, y equals 6x minus 3, which is our red line here, and y equals 4x plus 2, which is our blue line, we can very clearly see that they intersect one time at the point 2.5, 12. So 2.5, 12 lies on both lines. It makes both equations true. So that would be our solution. We can also solve this using one of our other methods like substitution or elimination. So let's try substitution for this one. So I'm going to plug in 6x minus 3 for my y value down here. So I get 6x minus 3 equals 4x plus 2. I can subtract 4x from both sides. 2x minus 3 equals 2. If I add 3 to both sides, I get that 2x equals 5. And I can see that x equals 2.5. I then take that value for x and plug it back into one of my equations to solve for y. And I can see that y equals 15 minus 3, y equals 12. So we have one solution here, which is the ordered pair 2.5, 12. These are unique solution problems, are all of the problems you have dealt with up until this point. Okay, we also have inconsistent solutions. These are when we have two linear equations in a system that never intersect. So we would call those parallel lines. So in this example, we have 3x plus 1, which is our red line, and 3x plus 4, which is our blue line. Both of these have a slope of 3, which means that they're parallel. They are never going to cross each other. They are never going to intersect. That means there is not one ordered pair in all of existence that would make both equations true, because one set of ordered pairs is completely different from the next because they're parallel lines and they never cross. If we were to try to solve this either with elimination or substitution, we would get something like 3x plus 1, if I was using substitution, equals 3x plus 4. I could subtract 3x from both sides, and I'm left with 1 equals 4. 1 never ever equals 4, which tells me that this system of equations has no solution. So again, if we have two parallel lines, then that would be no solution or inconsistent solution. And then our third type of solution for system of equations is dependent solutions. This is when our two equations are the exact same line. So they share every single ordered pair in common, which means there isn't just one point of intersection, but there's infinitely many points of intersection. So an example here could be 1/2 x plus 3 and y equals 3 minus 1/2 x. 3 plus 1/2 x. So if I were to just rearrange this second equation, I would get y equals 1/2 x plus 3, which we can see is identical to y equals 1/2 x plus 3. If I were to try to solve this with substitution, I could have 1/2 x plus 3 equals 1/2 x plus 3. If I subtract 1/2 x from both sides, I get that 3 equals 3, which is true. But again, I haven't actually solved for a variable, right? Because they've just canceled out 3 equals 3. These equations are the exact same line. They're right on top of each other, so they would have infinitely many solutions. So if your equations are the same, you have infinitely many solutions. If your lines are parallel but with different y-intercepts, you have no solutions because they will never intersect. And if you have different slopes, then you would have a unique solution or only one solution because your lines would intersect at exactly one point. So let's do a couple of practice problems. For these, you don't have to tell me what the solution is, just try to figure out how many solutions there are. Okay, so you can pause the video and try these on your own. And then when you're ready, we can look at them together. So our first example, y equals 3x plus 2 and y equals 7x minus 5. Well, already I can see that my first equation has a slope of 3 and my second has a slope of 7, meaning these two lines are not parallel and they're also not the same line. So that should tell me right away that this is going to be a unique solution, or I would have one solution because I have different slopes. In the example to the right, I have y equals 1/2 x plus 8 and y equals 1/2 x minus 10. Now in both of these equations, I have the same slope, but my y-intercepts are different. Now because my slopes are the same, that means that my lines are going to be parallel. So one is going to cross up here at plus 8, so 1/2 x plus 8, and one's going to be down here at 1/2 x minus 10. They're never going to intersect, so these two lines would be inconsistent solution or no solutions. Because we have, let me change my colors here, we have the same slope but different y-intercepts. In our next example, we have 2x plus y equals 10 and y equals 10 minus 2x. So what I'm going to do is I'm going to rearrange my first equation to be in y equals mx plus b form. So I have 2x plus y equals 10, and I just want to subtract 2x from both sides. So I get y equals 10 minus 2x. Now this equation and this equation are exactly the same. I have the same slope of -2 and I have the same y-intercept of 10. So this tells me that I'm going to have dependent solutions or infinitely many solutions. And that is because I have the same slope and y-intercept, so my equations are the same. So this would just be the same line. Okay, and then our last example, we have 6x plus 4y equals 1 and y equals -1/2 x plus 2. So I'm going to rearrange my first equation again to be in y equals mx plus b form. So I have 6x plus 4y equals 1. If I subtract 6x from both sides, I get 4y equals -6x plus 1. I can divide both sides by 4, and I get that y equals -3/2 x plus 1/4. Now both of these equations have a slope of -3/2 or -1.5, but then my y-intercepts are different. So same slope, different y-intercepts, that tells me my lines are going to be parallel, which means that I'm going to have inconsistent solution or no solutions at all, because these are parallel lines. You can get some more practice with this using the practice problems right below this video.